Hi, I'm Jeffrey Richard. We're here at Washington High School in Washington, Iowa. I teach math, physics, and Project Lead the Way courses of Intro to Engineering Design, Principles of Engineering, and Digital Engineering, as well as Bioengineering. First of all, we want to start off with and if you're watching this video, you probably know what SOHCAHTOA means. Sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent opposite over adjacent. But what you haven't seen is a visual. This is for my visual learners. Watch this. What if I simply have a circle? Make that 3 circles. One for my sine function, one for my cosine, and one for my tangent. Watch what we do. We'll make them a little pretty while we're at it. I call these pie shape. Sine of theta, opposite over hypotenuse. It doesn't take long before students don't need to print all of these out. They simply will do this. And for tangent, understanding also the reverse function of arc sine, arc cosine, and arc tangent. But watch this. What if the hypotenuse is missing? They immediately see this is a division problem, not multiplication. What if the opposite is missing? Now they see it's a multiplication problem because the items are side by side. So instantly, they can see how to solve for the missing item. Also, if the angle is missing, they will divide those and do the arc sine to find the angle. So, sine, cosine, and tangent in 3 circles. Now, since it's visual learners I'm dealing with, what if I want to know how tall a building is? Can I take this board protractor and this simple plumb bob weight, and if I stand a distance from a building, and then I look at the edge of this protractor and aim for the top of that building, can I now get the angle, the difference in the angle from my 90 degrees vertical to whatever that building was? And if I know how far away I am, now can I calculate the height of that building using SOHCAHTOA? How about if we're trying to do metric, the metric system? Many of you have trouble with students understanding the metric system. So watch this. You know this already. Going down, I have deci, centi, and milli. Then they do not name the next 2. But then they go to micro with a symbol like that. So check this out. If I happen to have 0.0298, and when I say that these were meters, it's not realistic to leave that in meters. So let's put them in centimeters. How do we do that? What if I had a capital Z I could work with? There's your starting point. Arrows on each end. I found that students have no problem understanding this scale, as long as it's vertical like this, base units in it, and a capital Z. So if I start here, my starting is at the meter, which is here on my base unit line. I want to go to centimeters, which is 2 steps down. So from here I'm going 2 steps down. This Z says if I go down, I go to the right. How many steps? 2. So this goes 1, 2 to the right. So I have 2.98 centimeters.